Before we begin, this documentary is an independently written educational narration inspired by publicly available astronomical research and space mission data. All explanations are presented in our own storytelling style to help viewers better understand the science of the universe. Out here deep into space and far away from the sun, you might expect everything to be frozen and lifeless, and yet we find images like this, captured by one of NASA's most advanced research probes that shows us these bizarre structures seemingly created by a process that is unlike anything we know on Earth. Jupiter's moon Io is more alive than any other body in our solar system. Its rocky surface is caught up in a raging battle between fire and ice. Meanwhile, scientists on Earth have only just begun to uncover the hidden forces that are driving this chaos. The Jupiter system is home to nearly 100 officially recognized moons, a number that continues to grow as we discover new objects orbiting the giant planet. Most of them are very small, but 4 are exceptionally large. We call these the Galilean moons, as they were first recognized by the 16th century astronomer Galileo Galilei using one of the first telescopes ever made. The outer 2 moons are the largest, Callisto and Ganymede. Both are solid orbs of ice and rock, with dead, heavily cratered surfaces. Second in line is Europa, which is made from a thin, smooth sheet of ice floating on a vast ocean of liquid water. It's one of the most promising locations in the solar system to find extraterrestrial life. And then, closest to Jupiter is Io, just 350,000 kilometers above the clouds of the gas giant, not much further than the distance between Earth and our moon, and about the same size, just a little bigger and heavier. Io is actually the most dense moon in our solar system, and that's because it's made almost entirely of rock and metal, while most of the other large moons out here are made of ice and rock. The difference is so extreme that Io is believed to have the lowest water content of any known body in the solar system, even drier than Mercury, the closest planet to the Sun. But what really makes Io special is the action on its surface. This is the only location outside of the Earth where we know that volcanoes are erupting on a regular basis. Io is actually the most volcanically active place in our entire solar system, with up to 400 active volcanoes dotting the entire surface of the moon. This discovery was first made by the Voyager 1 probe during its Jupiter flyby in 1979. Even from a distance of 20,000 kilometers and using primitive, low-resolution cameras, Voyager was able to see 9 distinct volcanic eruptions blasting out from the moon's surface. These raging lava flows exist in stark contrast to a world that is consumed by a deep freeze. Outside of the volcanic zones, the surface temperature of Io drops down to minus 130 degrees Celsius. We know that the Sun is too far away to contribute any warmth to the Jupiter system, so where does all of this heat come from? First, we need to appreciate that Io is caught up in a very treacherous location. At this close distance to Jupiter, it's just far enough away to avoid getting sucked in or even torn apart by the planet's massive gravity. But that doesn't mean that Io is in a safe place either. The extreme gravity from Jupiter still pulls on the moon's surface hard enough to stretch the rock and distort its shape. And then, on the other side, there are these other 3 large Galilean moons, and they exert their own force of gravity. Not nearly as strong as Jupiter, but still enough to pull Io in the opposite direction, which disrupts its orbit around Jupiter. So instead of moving in a circular pattern, Io orbits in an oval shape, meaning sometimes it's really close to Jupiter and other times it's further away. So it never gets an even exposure to that extreme gravity, and it cycles back and forth about once every 2 days, constantly being stretched and released and changing shape as it moves along. The result is that Io experiences some pretty massive tidal bulging. This is the same effect that we see with the ocean on Earth. Our own moon has enough gravity to pull up on the water, causing high and low tides. The rise of the ocean on Earth is only about half a meter on average. Different coastal locations will experience varying amounts of tidal change based on their geography, but in the middle of the ocean, the change is very small.
On Io, the gravity of Jupiter does something insane, lifting the surface by as much as 100 meters when the two bodies are at their closest distance. And that is not just pulling up water, that's stretching solid rock and essentially giving the moon itself a slight egg shape. All of this stretching and squeezing acts like a pump that drives energy into the center of Io and powers all of this volcanic activity. But these volcanoes do not function in the same way that we see on Earth. If you think about a volcanic eruption, you probably imagine a big pointy mountain with lava and ash shooting out from the top. These tend to form along areas where tectonic plates collide and force rock up from below the surface. Io doesn't have plate tectonics, so lava just tends to erupt from cracks that form as a result of the constant gravitational stretching. The initial release of energy can throw lava dozens of kilometers above the moon's surface, and above that, a plume of sulfur gas can rise for hundreds of kilometers. Sulfur is always present in volcanic activity on Earth as well. If you ever see lava rock that has all of these round holes all over it, those are created by trapped pockets of sulfur gas. The result is that a sulfur atmosphere surrounds Io. Depending on the level of volcanic activity at any given time, the atmosphere can range from about 1/3 the density of Earth's to nearly double. Most of the sulfur that gets released will eventually settle back down and cover the moon's surface. This is what creates the range of vibrant colors that we see from orbit. The yellow regions are sulfur that has been crystallized by the low temperatures, essentially snow. The white and blue patches are frozen sulfur dioxide, which exist in the coldest shadow regions of the moon. The green areas are sulfur monoxide, which is created by interactions with Jupiter's radiation belt in the upper atmosphere. And then the red areas are hotspots of recent volcanic activity, where the sulfur is still being actively heated. Going back to what we mentioned earlier, volcanic activity on Io does not create mountains or raised shield structures like it does on Earth. Instead, after the initial violence of the eruption, the moon's surface tends to collapse down and molten rock fills the void to create these giant lava lakes. The biggest one is named Loki Patera. It's 200 kilometers in diameter, and in the center there's a big island of solidified rock surrounded by an active churning lake of molten rock. Now, because of all this volcanic activity, you might think that Io is composed just like the Earth, with a solid crust layer floating on top of a magma ocean. But we're pretty sure that's not the case. Probes sent to the Jupiter system have been able to measure the gravity field of the moon, and what they notice is a very uneven pull of gravity around the surface. That tells us the magma is not evenly distributed. It's probably trapped in localized pockets of molten rock that are created in the areas that experience the largest amount of tidal flexing. So what you end up with are hundreds of separate volcanic engines hidden underground, which means every volcano is going to behave a little differently. Okay, here's another mystery. If volcanoes and plate tectonics aren't creating mountains on Io, then where did this thing come from? This is called Steeple Mountain. At somewhere between 5 and 7 kilometers in height, it's one of the most iconic views associated with Io, mostly because it looks a lot like the spire of a church steeple or the Eye of Sauron. We are able to see such detailed images like these thanks to data collected by NASA's Juno spacecraft, which arrived at Jupiter in 2016 on a 5-year mission to study the atmosphere of the gas giant. After completing that goal, Juno was repurposed to investigate the 4 Galilean moons. The probe completed 2 close flybys of Io, the first in December 2023 and a second in February 2024, coming within 1,500 kilometers of the surface. What Juno saw out there is possibly the most unique landscape in our solar system. They quickly found that Steeple is actually just one of many tall, spiky mountains dotted around the surface of Io. The tallest of them rises to 18 kilometers, or about double the height of Mount Everest. And what's really interesting is that unlike Everest, these structures on Io are all just kind of lone wolves. There are no dense groupings or mountain ranges to be found, just these seemingly random peaks stabbing straight up into the air. That tells us that these mountains did not form slowly over time. Instead, they burst from the ground suddenly, like an alien from a guy's chest in that movie Alien. Now, we're pretty sure that this is all still linked to volcanic activity, but in a very unusual way. So earlier we talked about how the lava flow tends to cause the surface of Io to collapse and form these giant lakes. The idea is that this downward pressure into the surface actually causes a nearby area of rock to get pushed up. Imagine if every time a sinkhole on the Earth, a new mountain just sprung up right beside it. That is kind of what we're looking at here. The result would be unlike any mountain you've ever seen, and this is the kind of bizarre natural process that has been playing out on Io for billions of years, with the surface in a constant state of rise and fall, thanks to the relentless pull of Jupiter's gravity. Sadly, though, these images could be the last we ever see of Io. With NASA's Juno spacecraft slowly running out of fuel, it's set to be replaced by two new